Hello, Chichiman, Chi Hin Chan, and Carol Amanda de Vera. Guys, can you hear me? Hello, Carol. Why is your camera off?
Oh,
Chi Hin, how about you? Okay. Carol, are you ready for the class?
yes.
Very good. Carol, you are grade 7, right? Right now, what grade are you?
Grade 7.
Grade 7. Okay, good. Chi Hin Chan, are you there? Carol, where are you from? From Philippines.
Yes.
Okay, good. So Carol, now let's start our class. Okay, that is 1 hour class, I think. Actually, 1 hour, maybe 15 minutes. So today we will talk about divisibility. Okay, and we will just practice a few questions. And actually, we have around 10 questions. Let's see how much time actually we have. I mean, how many questions we can do. Carol, here I will just keep teaching and explaining everything in detail. All right. If any step is not clear for you, immediately you can raise your hand and ask. Okay. Because this is one-to-one or maybe just small group. All right. If you just keep only listening and I talk here, you may not understand much. Okay. If any step is not clear, you just stop. Mr. Qasim, why is this so? What did you do here? And blah, blah, blah. You can ask any question. I mean, just feel free to ask any question during the class time. Okay, Carol?
Yes.
Good. So now, Carol, can you read the first question? Read the first question. Carol, can you read the first question?
How many integers which are divisible by 3, 6, and 9 simultaneously within 1 to 100 are there?
Okay. So how many integers, right, which are divisible by 3, 6, and 9 simultaneously within 1 to 100 are there? Okay. So that means that to find these integers, right, we are looking for integers which is divisible by 3 and 6 and 9 simultaneously, right? And what are those numbers? To find this one first, we need to find what is the least common multiple of these numbers, 3, 6, 9. And you know how to find this. What is the least common multiple of 3, 6, and 9? That is 18, right? And 9 is not divisible by 6. And the second multiple of 9 is 18. 18 is divisible by 3. It's divisible by 6. So 18 is the last, what is it, least common multiple of these numbers. So now for a number to be divisible by these numbers, right, it must be a multiple of 18. Otherwise, it will not be divisible by all these numbers simultaneously. So that means that now from here, right, and just a small number, that's why here we have 18 and you have 36, right? And the last number is, what is it? It is 90, which means that this 18 is 1 times 18 and 90 is 5 times 18, right? So how many numbers do we have here? How many integers do we have here from 1 to 100, which are divisible by 3, 6, and 9 simultaneously? It is 5. Okay, is it clear?
Yes.
Good. Now, in the next question, read the question, Carol.
How many integers which are divisible by 5 or 8 within 1 to 200 are?
Okay. So again, how many integers which are divisible by 5 or 8? Right? It says 5 or 8 within 1 to 100, right? So that means that's okay. So that means that we are looking for a number, but now here, or how should we understand? Okay, it's not in our daily life situation, right? For example, if you go to a restaurant, if I ask, what would you like to drink? Is lemonade, or for example, as a Coca-Cola or Fanta. Okay, that means that you need to choose one of them. But in math, when we just say that or, That means that we are looking for a number, either it is divisible by 5 or 8 or both, right? So how many integers which are divisible by 5? We need to find this, right? Until 1 to 100. I mean, between 1 and 200. That is 5 and 10 and dot dot. Here we have 200. How many numbers are divisible by 5 between 1 and 100? That is, we have 40, right? And how many numbers are divisible by 8 between 1 and 200? And here we have 8 and 16 dot dot. And the smallest, I mean, the biggest integer that is divisible by 8, but it is less than 200. What is this? Uh, Also 200 is divisible by 8, right? That is 200. How many do we have here? Here we have 25, right? So now actually some numbers are counted twice, right? For example, 200, I count also for 5 and also 200 for 8, right? Actually, we are looking for how many integers which are divisible by 5. Actually, we are looking for different integers. I cannot count 200 twice. So now I need to find the numbers which are divisible by 5 and 8 together. So that is, what numbers are divisible by 5 and 8 together? That those numbers are multiples of 40, right? Because 5 and 8, the least common multiple is 40. So the 40 and 80, blah, blah, here we have 200. How many? 200 is 5 times 40. Here we have 5, right? So now then, how many integers which are divisible by 5 or 8 within 1 to 200? So that is 40 plus 25, right? Altogether, these numbers are divisible by 5 or 8, and minus some numbers are counted twice. The number of duplicated numbers here, it is 5, which is equal to 60. So the answer is we have 60 integers between 1 and 200, and which are either divisible by 5 or 8. Okay, Carol, is it uh, understood?
Yes.
Okay, good. Now let's move to the next question. Find the GCD of 12443 and 16771. Okay, so how do you find the what is the GCD? It is the greatest common divisor of these numbers, right? Okay, so what do you think, Carl? How do you find the highest common factor or greatest common divisor? They mean the same thing. In Philippine, how do you use GCD or ACF?
Call that as GCF, or greatest
ACF,
common factor.
highest common factor, right?
Yeah, but it's greatest common factor, GCF.
Greatest common factor. Okay, then also actually it is GCF. Okay. In some countries like Singapore, for example, they call this highest common factor. Maybe in Hong Kong, it is greatest common divisor or greatest common factor. They all mean the same thing. Okay, they all mean the same thing. Okay, so now I'm going to just write something here. Okay, Carl, look. Here, these are the big numbers. Okay, if you just keep dividing these numbers by prime numbers, still we can get this, but it may take a long time. Okay, suppose that this 1, 2, 4, 4, 3. Okay, and they have a common divisor of, let's say it is A. Okay, or let's say it is N. So if I divide this number by N, let's say here we have N times A. N and A are both integers, suppose. And also here we have 16771. Suppose that also it is divisible by N, and here we have some number B. Okay, like every number we can write like this, right? For example, let's say 8, I can write it as 2 times 4, right? Or 12, for example, I can write it as 2 times 6. Okay, what I'm trying to do here is, as you see here, this 2 is a common factor. Now, if I just subtract side by side, 12 minus 8, right? At the time here, we have 2 times 6 minus 2 times 4, which means that 2 is a common factor. I can take this out, 6 minus 4. So from here, that means that if this 1, 2, 12,443 is divisible by n, and 16,7771, that's divisible by n, we are looking for this n, right? And that is, what is it? greatest common divisor of these numbers. Then also their difference must be divisible by n. Why is it so? Because again, if you just subtract side by side, here we have 16,771 minus 12,443. On the right hand side, I have n. N is a common factor. Here we have b minus a. So BA, these are just integers. N is just common factor. Now in this way, I can find N much faster. What is the difference of these two numbers? The difference is 4, 3, 2, 8. Okay. So actually, I can just write it as 8 times 541 because this number is divisible by 8. And if you divide this by 8, so the what is it? I can just write it as a product of 8 and 541. Okay. So that means that here, this 541 or 8 here, right? Actually, here, this one is a prime number. So 541 must be, that means that this 4328, it must be divisible by 541. That is a common factor. This is our n. Okay. So because why it's not 8? Because this actual difference, they are small numbers. They are small numbers. So it n should be equal to either 8 or it should be equal to 541. But I'm looking for this 541. And now 541 is a prime number. It is a prime number. So GCD of these new numbers, 12,443 and 16,771 is, what is it? 541. So now I can just, if you just divide this by 541, you can get the answer here. 541, you get the answer. What is it? 12 times 443. 12 times 443 is divided by 541. That's equal to 23. So here we have 23. And how about 16,771 is divided by 541? The answer is 31. Okay. As I say here, this 541 is a prime number, 23 is a prime number, 31 is a prime number, 541 is a prime number. But what is the common factor of these numbers? Highest common factor, that is 541. So our answer is 541. Okay, Carol, did you understand?
Yes.
That's a key point here, Carl. Actually, if two numbers have common divisors, and also their difference actually must have that common that common divisor must be the common divisor of their difference. Okay, and at the time, actually now this number is much smaller. I can find a common divisor much faster. Okay, how about another question? Question 4. It says find the GCD again, greatest common divisor of these numbers. Okay. Again, I'm going to use the same idea, the same technique, because these numbers are big numbers, and you may just keep actually dividing these numbers by prime numbers, starting with 3 and 5 and 7. In this way, also you can reach this. But here I'm going to use this method. Here again, suppose that they have this GCD, okay, of this number 5658 and 6765 and 6970. Okay, suppose that they have a common, what is it, greatest common divisor of M. Okay, so that means that this 5658, I can write it as M times some number. Let me just write it X. I don't know what is X. And the second number is 6765. Also, it is divisible by M. And if you divide by M, we get some number Y. And 6970, that's equal to M some number Z. All of these numbers, actually, they are natural numbers. This M, X, Y, Z, they are natural numbers. I'm just writing as a product of these two numbers. Now, what is the difference of these two numbers? That is 6765. 6765 minus 5658. On the right hand side, the difference of the left hand side. M is a common factor, so I can write it as Y minus X. And how about the second one? The difference of these two things, that is 6970 minus 6765. On the right hand side, M is a common factor. Here we have M and Z minus Y. right? So now if you just find that your differences, what is the difference of these two numbers? The difference of these two numbers is 1107. 1107. And how about the difference of these two numbers? If you subtract this, it is 205. Now 205 is a small number, right? Actually, if you just factorize this, 205 is equal to 41 times 5. Now, if you check this 1107, is it divisible by 41? If you divide by 41, the answer is 27. So actually, again, these two numbers, right, they have a common factor here, 41. So that means that from here, then I draw a conclusion. This m must be 41. Okay. So now from here, if you check this, 5, 6, 5, 8. If you divide this by 41, 5, 6, 5, 8, divide by 41, what is the answer? It is 41 times 138. And how about 6765? And 6765 divided by 41 again, that's equal to 41 times 165. And the last number is 6970 and divided by 41. 6970 divided by 41, the answer is 107. So now if you look at these numbers, 165, 138, 170, right? They don't have any common factor. How do I know? The 170, for example, it is just 17 times 10, right? And the first number is not divisible by 10, and also it's not divisible by 7. Okay, so that means that the only highest common factor, of these numbers is 41. So the answer is GCD of these numbers is 41. Carol, any questions so far?
None.
Very good. So now let's move to the next question then. Simplify. Okay, 5, 4, 5, 1. How do we simplify this? Again, to simplify this, Carol, as you know, they must have some common factor, right? Except for 1. So that actually we can just write it as a factor of or as a product of that number, right? And after that, we can just cancel out their common, what is it, factor. So number one, again, I use the same method. What is the difference of these numbers? 8, 5, 3, 2 minus 5, 4, 5, 1. Okay, because if they have any common factor and also their difference actually must be divisible by that common factor. And what is the difference of these two numbers? 8, 5, right? 8, 5, 8, 5, 3, 2 minus 5, 4, 5, 1. That's equal to 3081. 3081, right? So now from here, as you see here, this number, just we can check, is it a prime number or not? But if you just look at the sum of the digits of this number, 3 plus 8, 11, 11 plus 1, it is 12. We know that if the sum of the digits of a number is divisible by 3, and also it must be divisible by 3. That means that I can divide this by 3. If you divide this by 3, then here we have 1027. And 1027, 3, it's not divisible by 7. For example, let's say 11. No, how about 13? 1027. If you divide this by 13, it is divisible by 13. So I can write it as 3 times 13 times, what is it? 79. Okay. So number one, actually, I know that these two numbers are divisible by 3. Okay. So let me just write them. 5, 4, 5. 1, if you divide by 3, it is 1. 24 divided by 3, it is 8. And 5, it is 1. 21, it is 7. Over, if you divide 8, 5, 3, 2 by 3, it is 2. 25, 8, 13, 4, and 12, it is 4. Okay, here we have 3 times. 2,844 and 1870. So now this 3, 3, it is gone, right? Again, at the top, actually, this 1817, right? 1817, we can write it as 13 times 79 over How about 2844? 2844, if you divide this by 13, um, it's not divisible by 13, but if you divide, what is it, 284, it should be divisible either by 13 or 79. Otherwise, we cannot actually simplify this. That's why I'm just trying 2, 8, and 4, 4. How about if you divide this by 79? So if you divide by 79, this 2844, that's equal to, what is it, 36 times 79. Now from here, this 79, 79, they cancel out each other. Here we have 13 over 36. So here, the simplified form of this fraction is 13 over 16. Okay. Again, what method we are using here is if these two numbers have a common factor, and also their difference must be divisible by that common factor. If you find their difference, now we have smaller number, 3081. When you factorize this, that's equal to 3 times 13 times 79. Okay. And after that, I just check the denominator. Is it divisible by 3? Yes. Immediately, I just factorize this. Is it divisible by 13? No. Is it divisible by 79? Yes. So that's equal to 36 times 79 and cancel out the common factor. And that's it. Okay, Carol.
Yes.
All right. Carol, can you read question 6?
If the remainders of dividing three-digit number n by 7 and 11 are equal to 5 and 9 respectively, how many possible values does n have?
Okay. If the remainders of dividing three-digit number n. So here we are talking about a three-digit number. That's our n. We just actually denote this by n. That is a three-digit number. Okay. So the remainders of dividing three-digit number n by 7 and 11 are equal to 5 and 9 respectively. How many possible values does n have? Okay. So once again, Carl, if you remember that we just write here, we know that if you divide 17, for example, by 5, right, the quotient is 3, and here we have remainder 2. And every number, it can be written like this, right? If you're talking about some number n, if you divide this by some d, we call this divisor, and you have quotient here, and here we have a remainder. Every number can be written in this form, right? And sometimes remainder may be 0. That means that we just say that that number is divisible by d. So in similar way, I'm talking about this n, and it is saying that when we divide by 7, right, the remainder is 5. When you divide by 11, the remainder is 9. So what does it mean? It means that if I divide this by 7, I have some natural number here. Let's say, let me denote it by capital A. Okay, it's a natural number. And the remainder is 5, right? And again, if you divide the same number, this n, by 11, I have some quotient. Let's just denote this by capital B, okay? So what we have here, the remainder is 9, okay? The question is, how many possible values does n have? Okay, and how many three-digit numbers we have, so that when you divide by 7, remainder is 5, and if you divide by 11, remainder is 9. Okay, now again, actually we did similar questions before. If I just add 4 to both sides of these equations, what happens here? I mean 2 to the first one, n plus 2. Here we have 7 times a plus 5 plus 2. I just added 2 to both sides of the equation. So here we have 7a plus, what is 5 plus 2? It is 7. So here we have 7. And 7 is a common factor, 7 times a plus 1, right? What does it mean? It means that if you just add 2 to the number, it will be just a factor of 7, or it will be divisible by 7. And how about the second one? Again, as you see here, if I just add 2 on the right hand side, we have 11 times b. Now 9 plus 2, that's equal to 11. So here 11 is a common factor. I can just write it as b plus 1. This capital A and capital B, they are some natural numbers. Now from here, what do you understand, Carl? As you see here, if I just add 2 to the number, right, it is divisible by, what is it, 7 and 11, right? So now what we mean, what we understand from here, that means that this n plus 2, right? That means that that's our first step. That means that this n plus 2 must be, what is it? Multiples of 7 and 11, right? Because n plus is divisible by 7, it is divisible by 11, which means that it must be multiples of 77. Okay. So that means that now n plus 2, we know that it's a 3-digit number. What is the first 3-digit number? That is a multiple of 77. So that means that here, this n plus 2, right? So those numbers are, the 77 is not 3-digit number. Second multiple of 77 is 154, right? So that is, what is it? 2 times 77. That is a 3-digit number. 1 times 77, it's not a 3-digit number, so we don't take this. And next one is 3 times 77, right? Next one is 4 times 77, and dot dot. And the last one is, what is the last one? That is less than 1000 or 1002. Here we have 13, right? Here we have actually 13. The 13 times 77, because 13 times 77, what is 13 times 77? Let me just write here. 13 times 77 is equal to 1001. Okay. So now, because here we have n plus 2, if we just take to the left-hand side, also this will be less than 1000. Okay. So what are these possible numbers then? These possible numbers of n are these numbers. The first one is 2 times 77 minus 2. Next one is 3 times 77 minus 2, dot, dot. And the last one is 13 times 77 minus 2, which is equal to 999. How many numbers do we have here? We are starting with 2, right? And the last one is 13. So 13, right? Starting with 2. So here we have 12. So the answer is we have 12 such numbers. When we divide by 7, remainder is 5. When we divide by 11, remainder is 12. I mean, 9. Carol, do you have any questions?
None.
Do you really understand everything here, Carol?
Yeah.
Yes or no? Hello, Carol, say
Yes.
something. Okay,
Yes.
good, good. All right, because Carol, these questions are thought-provoking questions, and also it requires a lot of experience. Okay, and after this class, again, I suggest you to write them down and try to solve these questions yourself. Okay, can you do that or not? If you can do, that means that you understood everything. Otherwise, still you need to practice one more time. Okay, another question, Carol. Here, given this A3726B is divisible by 72. Find the number. Okay. So by saying divisible by 72, what numbers are divisible by 72? And we know that if this one is A3726B, right? It is how many digit number? It is 6-digit number. Divisible by 2 means I can write it as 72 times some number. Let's say it is M. M is a natural number. What is 72? 72 is just 8 times 9, right? Times n. And we know that this 8 and 9, these two numbers are relatively prime numbers. That means that only common factor to these numbers is 1. They don't have any common factor different from 1. So that means that for a number to be divisible by 72, that number must be divisible by 8, and it should be divisible by 9. And if you remember, Carol, what numbers are divisible by 8 if the number which is formed by the last 3 digits of the number, right? Divisible by 8. Then that number is divisible by 8. So that means that this 2, 6B, that's our 3-digit number. This must be divisible by 8. The first part. And number 2, to be divisible by 9, we know that the sum of the digits of the number must be divisible by 9, right? So what is the sum of the digits of this number? It is a plus 3 plus 7 plus 2 plus 6 plus b. Now, if you simplify this, 3 plus 7, it is 10, 2 plus 6, 18. So here we have 18 plus a plus b. It should be divisible by 9, okay? For this 3 dot means that it is divisible by 9. Now from here, actually, what number actually divisible by 8 between 260 and 270? Okay, usually we know that numbers which are divisible by 8, those numbers are even numbers, right? So odd numbers are not divisible by 8. So if you just check this, for example, 260, for example, is it divisible by 8? If you divide by 8, it is 324. Here we have 20. It's not divisible by 8, right? 20 is not divisible by 8. So this doesn't work. Next number is, how about 260? 3 times 8, 24. And subtract this 22. Also, it's not divisible by 8. As you see here, because of this 2, right? This number, if I write here 4, then it will be divisible by 8. So 264, right? It is divisible by 8. 3 times 8, 24. It is 2. Here we have 24. It is 2. So that means that now I know the value of b here. Then. What is the value of b? B is equal to 4. Now, if you substitute into here, here we have 18 plus a plus 4, which is equal to 22. 18 plus 4, 22, plus a. Now, this should be divisible by 9. So immediately we know that what number is divisible by 9, which is greater than 22. The first number is 27, which means that this a must be equal to 5, right? If you substitute here, 22 plus 5, 27. 27 is divisible by 9. So now we got the answers then. Here, a must be 5 and b must be 4 for the given number to be divisible by 72. Okay, Carl.
Yes?
So far, any questions?
None, sir? None,
Are you
sir.
sure?
Yes.
Good, Carl. If you understand everything, let's move on. Now we have another similar question, question 8. It says that given that this 5, 8, 6, 4, AB 414 is divisible by 91. Find the value of A and B. Okay. Again, how you get this? Number one, the first observation is we know that 91 is equal to 7 times 13, right? And 7 is a prime number, 13 is a prime number, and all actually, if you just pick any two prime numbers, they are relatively prime. Why? Because the only common factor to these numbers is 1. So now again, for this given number to be divisible by 91, it should be divisible by 7, and it should be divisible by 13 at the same time. That means that simply this number must be divisible by 7 and 13 simultaneously. Now, if you remember the rule, for example, what numbers are divisible by 7? So now if I just write this number, the second observation is divisibility by 7. So here we have 5, 8, 6, 4, A, B, 4, 1, 4, right? That is just a single number. So now we need to group them in 3. So from here, the first 3-digit numbers, and the second 3-digit numbers, and the third digit numbers, right? I would just name them actually. The first group of 3 numbers, we call them odd order. This one is even, and this one is odd, right? Because this is the first one, the second group, and third group, fourth group, fifth group. It continues if you're talking about big number. So now, when actually this number is divisible by 7 or 13. First, let's talk about divisibility by 7. If the sum of the numbers in odd orders, right? That is, what is it? 414 plus 586 minus in even order. That is 4AB. is divisible by 7, then it is divisible by 7. Now I'm suppose that since it's divisible by 91, so actually it should be divisible by 7. 7 times some number. Let's say this capital A. In a similar way, how about divisibility by 13? Okay, divisible by 13. Again, the same thing. 4, 1. 4 plus 5, 8, 6 minus 4ab. Actually, this difference should be divisible by 13. So if you divide by 13, let's say our quotient is b. Now from here, what is 414 plus 586? That's equal to 1000, right? And another observation from here, let me just write this. That is 1000. And this 4ab, right? It is a 4-digit number. It is 400. It is 400 and something. 400, A 10 units, B 1 units. So we can write it as 400 plus this digit A and B. Okay. So now if I just rewrite those things, let me just write your third one. Okay, write those things again. 414 plus 586, that's equal to 1000 minus this 4AB, this 3-digit number. I can just write it as 400 plus AB. Okay. So still that's divisible by 7. And also that's divisible by 13. Okay, again, 1000 minus 400 plus AB is divisible by 13 something. Now from here, 1000 minus 400, that's just equal to 700 minus, here we have 2-digit number, which is equal to 7a. And here we have 700 again minus AB is equal to 13b. Okay. Now from here, what do we see here? That's 700. Why did I write 700? It is 600, right? 1000 minus 400, it is 600. And 1000 minus 400, it is 600. All right. So now, okay. Okay. Now let's continue. So I want to just simplify a bit more. From here, 600 AB. Okay, this 600, 600. Okay, so all right. Let me just write AB here. What is AB from the first equation? It is 600 minus 7A. From the second one, what is AB? It is 600 minus 13B. And what is the smallest number less than 600 that is divisible by 7? And if you divide 600, for example, 599, right? 599 and divided by 7, that's equal to, no, it is 601 divided by 7. Um, all right, 401, it is 700. The 600s, if you divide anyway, let me just write here, then we'll count it. 600 divided by 7, it is 8, 40, it is 5, so it is 5. So that means that I can just write it as 7 times some number plus 5. Well, which means is equal to 2. All right. Just a minute, Carl. Just a minute. Okay. So this one is 1000. This one is 400. Okay. AB 415, 14. All right. That's equal to 600. 600 minus AB. That's equal to 7 times A. And here we have 600 minus AB. That's equal to 13 AB. And if you just write 600, 600 is equal to 7 times, what is it? 600. All right. 600. All right. 85. So here we have 85 plus, what is it? 7 times 85. So that's equal to 5. Okay. And how about 13? 600, I can write it as, okay, 5 times 600 divided by 13. That's equal to 46. So it's 13 times 46 plus is equal to 2. Okay. So let's continue here. Here we have 600 minus AB is equal to 7A. And the second one, 1000 minus 400, that is 600 minus AB is equal to 13B. Now the 600, if you divide by 7, the remainder is 5, right? And if you divide by 13, remainder is 2. So here we have, if I actually, this AB is equal to 600 minus 7A. If I just add actually 2, it will be divisible by 7, because from this 5, right, if I just add 2, that is AB plus 2, and I have here something X here, because this 600, if I just add 2, it is 602, that's divisible by 7. And how about the second one? AB, because of here, this 13, right? If you just add 11 plus 11, that is divisible by 13. Okay. Now from here, what numbers actually in two-digit numbers, when we add 2, it is divisible by 7, right? If you just write down here, for example, those numbers are 12 and 12 plus 9. Let's just talk about first the second one. And the numbers, when we actually add 11, those numbers are divisible by 13. Okay. So that means if I just add 2, it is divisible by 13. What is it? Those numbers are, it is 15. Here 15 plus 13, 28. And 28 plus 13, it is 41, right? And as you see here, 15 plus 11, 26, divisible by 13. And even I should start, okay, 2 is not a two-digit number. And 41 plus 13, it is 54. And 13, 67. 13, it is 80. 13, 93. As you see here, this AB is 15. 15 plus 11, 26, divisible by 13. 28 plus 11, 39, divisible by 13. So among these numbers, which one actually, when we just add 2, it's divisible by 7. If I add 2 here, 17, not divisible by 7. If I add 2, 30, not divisible by 7. So if we add 2, not divisible by 7, it is 2, not divisible by 7, plus 2, not divisible by 7. And 17, okay. AB is 15, all right. If I add 2, 17, okay. 28, 30, 41, 43, 54, 56, okay. 67, 69, all right. 80, 82, 7, 93, 95. 602. Carl, this question, where did we make a mistake here? Huh? Why we cannot get the answer?
Well,
Where am I making a mistake here? Okay, Carol, now let's just think one more time, okay, and the divisibility, and after let's see if you can see the mistake, okay, otherwise maybe I will solve this later and share it with you. So here we have 5864, AB 414. Our question is correct. And it's divisible by 91. 91 is 7 times 13, right? That's correct. So to be divisible by 7, the sum of this digit 414 plus 586, that's equal to 1000 minus 4AB, right? That is the divisibility rule. Um, so it should be divisible by 7, and 414 plus 586 minus 4ab. Also, it should be divisible by 13 times b. So which means that here we have 600 minus ab, that is 7a. 600 minus ab, also it is 13b. Okay. So from here, 600 is 7 times 85 plus 5, and 600 is 13 times 46. 13 times 46, that is 598 plus 2. Okay, so now if you just wrote there, it is 7. Okay, so that is plus 2 AB. Okay, am I making a mistake here? Okay, just a minute here. All right, so this 600, I can write it as 7 times 85 plus 5 minus AB is equal to 7 times 8. So that means that here take AB to the left hand side, AB, or if you just add 2, okay, AB plus 2 is divisible by some number. And this one, if you just add x to this side and divide, subtract by 2, AB, right? Plus 2 means subtract, okay, plus 11, plus 11, okay, plus 11, that is divisible by 13. So if you add 11 to these numbers, what are these? It is 2, 15, 28, okay. And when you just add 2, it should be divisible by 7. 17, no. 29, 30, no. 43, and 56, 69. Okay, this should be minus 2, right? 65. Okay, with the 65, okay. 65, just a minute, minus 65 and divided by 13. Okay, Carl, let me just skip this, okay? For now, I will discuss this later because taking time, I think somewhere I made a mistake and we cannot see it right now. I will do this later and share it with you. Okay. So actually the answer, it should be, it is 27, 29, 27. Okay. So, okay. Anyway. So here, Carl, we have part B. A few minutes left. All right, no problem. How many integers which are not divisible by 4 or 5 within 1 to 100 are there? Okay. So here, which are not divisible by 4 or 5 within 1 to 100? Carol, what do you think? How do you find the number of these numbers? Just tell me your methods.
I first get divisibility by 4 and divisibility by 5, and then subtracting the divisibility by 4 and 5, and then subtracting the 100 minus all the numbers divisible by 4 or 5.
Very good. Very good. So at the time, first, how many integers which are not divisible by 4 or 5? So we need to find the numbers which are divisible by 4 or 5 and subtract from 100. It gives us the answer. Very good. So how many numbers are divisible by 4? It is 4 times 1, 4 times 2, dot, dot, 4 times 25. So here we have 25 numbers are divisible by 4. And how about by 5? 5 times 1. And here we have 5 times 20. We have 20 numbers. And divisible by 4 and 5, those numbers are 20 and 40. It is, what is it? 5 times 20. So here we have how many? Only 5. So altogether it is 25 plus 20 minus 5. That's equal to 40, right? And here we have 100 minus 40. So we have 60 numbers which are not divisible by 4 or not divisible by 5. Next number, the question, the sum of A, B, and C is 75, right? The quotient and remainder of dividing A by B and dividing B by C are equal to 4 and 2 respectively. Find the value of B. This is a little bit tricky question. If you don't understand the question, I think you cannot solve this. What is the first part? It says that it's A plus B plus C is equal to 75, right? And it says that the quotient and remainder of dividing A by B and dividing B by C are equal to 4 and 2 respectively. That means that if you divide A by B, that means that B here, and we have some result here, quotient, right? And that is equal to 2. No, it means that if you divide this A by B, the quotient is 4, remainder is 2. So that means that it is 4 times B plus 2. If you divide B by C again, right? If you divide B by C, the quotient is 4, 4, and the remainder is 2. It means this. Okay, I think if you don't read well, you may not understand this question. Now from here, this relationship we can find. What is A in terms of B and B in terms of C? So I'm going to express everything in terms of C here. So 4 times, what is B? B is given here. It is 4C plus 2. And here we have plus 2. That is 16C plus 4 times 2 is 8. 8 plus 2 is 10. Right? So now if you substitute into this equation, what is A? A is 16C plus 10. What is B? It is 4C plus 2. And C is just C. On the right-hand side, we have 75. And
I
16,
think I found a mistake.
huh?
Wait, is it? Wait,
What happened, Carol?
oh, sorry for that. Oh, wait, why is it 4B plus 2 and 4C plus 2? I have a question.
Yes.
Why, wait, how it became 4B plus 2 and 4C plus 2?
Carol, which part are you talking about? I mean, this part?
Yeah.
Okay. In the question, Carol, as I told you, if you don't read well, you don't understand this question. It says the quotient and remainder, okay, of dividing A by B and dividing B by C are equal to 4 and 2 respectively. If you just close this part, for example, just close this part and read this. And the quotient remainder of dividing A by B is 4 and 2. What do you understand from here? That means that if you divide A by B, the quotient is 4, remainder is 2. How do you write this? That's equal to 4 times B plus 2. That means that if you divide A by B, the quotient is 4, remainder is 2. And the second part, again, the same thing. If you divide B by C, now I'm dividing B by C, the quotient is 4 and the remainder is 2. Okay, Carol?
Yes.
That's why actually, if you don't read this well, you may not understand. Actually, a lot of students make a mistake in solving this question. So after that n, after that, I have to express all a, b, c in terms of one variable, either in a or in b or in c. But here I just did this in c, and instead of b, write 4c plus 2, and to simplify this, here we have 16c plus a. This one is a plus b plus c is equal to 75. Or if you simplify this 21c, 10 plus 2 is 12, take to the right hand side. So 21c is equal to 63. Now from here, c is equal to 3. If c equals 3, now we can write what is a, what is b, what is c. C equals 3. A is 16c plus 10. 3 times 16 is 48. 48 plus 10, that is 58. And how about B? B is 4 times C plus 2. 4 times 2 is 12. 12 plus 2 is, it is 14. So the sum of these numbers is, what is it? 75. As I see here, if you divide, for example, what? A is for A is 58, right? A is 58, B is 14. B is 14. So if you divide 58 by 14, the remainder is 2 and quotient is 4. If you divide 14 by 3, remainder is 2 and the quotient is 4. And the sum of these numbers is 75. Okay, Carol?
Yes.
Good. Carol, can you read this question?
N is a positive integer. If the remainders of dividing n by 3, 5, and 7 are 1, 3, and 5 respectively, find the minimum value of n.
Okay, well, I think a lot of examples similar to this. I don't know if you remember this. Again, I'm just using what? Okay. Here, n is a positive integer. If the remainders of dividing n by 3, 5, and 7, right, are 1, 3, and 5. What does it mean? Again, n, if you divide it by 3, and the quotient, I don't know, a, the remainder is 1. Again, n, if you divide this by 5, and quotient is some number, let's say this b, and the remainder is 3. And n, if you divide this number by 7, we have some number, quotient, it is c, let's say, and the remainder is 5, right? Find the minimum value of n. And if you notice here, if I just add 2 to all sides of this equation, right? Here we have n plus 2. Here we have 3a plus 2. What is this? 3 times a plus 1. Which means that if I add 2 to the n, it will be divisible by 3. The same thing, the second equation, if you add 2n plus 2, I have here 5b plus 5, which is 5 times b plus 1. That means if I add 2, that number will be divisible by 5. And the last one again, n plus 2, that's just equal to 7 times c plus 1. What does it mean? It means that n plus 2 is divisible by these numbers. So we are looking for that number, right? That the minimum value of n. So this first, let me find n plus 2. What is n plus 2? It is least common multiple of 3, 5, and 7. And all of these numbers are prime numbers, so that's equal to 105. Now from here, what is n? N equals 105 minus 2, that's equal to 103. So the smallest number, when we divide by 3, 5, 7, leaves the remainder of 135 is 103. Okay,
Yes.
good. Another example, the remainders of dividing 74, 112, and 169 by d are equal. And find the value of d. Okay, this I think is quite easy question. The remainders of dividing. So we divide 74, right, by d. Okay. So that's the remainder is x. I mean, the quotient is x. And it said remainder is the same. So let's say our remainder is r. And again, 1, 1, 2. Again, if you just divide this by d, our quotient is y. The remainder, again, it is r. Again, here we have 169. If you divide this by d, quotient is z. Again, remainder is r. Right? Now, again, actually, I'll just use the idea that if two numbers, actually, when we divide by d, remainder is r. How about if we subtract 1, 1, 2 minus 17? It is, why did I write 17? It's 74. It is 74. 74. 74. On the right hand side, r minus r, it is 0. So here we have d y minus x, which means that actually the d is also common factor of, divisible by the difference of these two numbers. How about 169 minus 112? If you subtract this, r minus r 0. So here we have d common factor, z minus y. So now if you subtract them, actually find the differences. What is 112 minus 74? It is 26, 38, right? It is 38. And how about 169 minus 112 is equal to 57, right? So actually these numbers, do they have a common factor? Yes, it is 19 times 2. This one is 19 times 3. So on the left hand side, I have d times something, right? And these parts are different. So here we have 2, 3, these parts are different. So which means that d must be equal to 19. So if you check this, if you divide 74 by 19, right? So 74 by 19, what is it? It is 4, not 4, it is 3, right? 57. 57, the remainder is 17, right? And 112, if you divide by 19, it is 5. 95, it is 17. And if you divide 169 by, again, 19, it is not 9, it is 9. 90, 81, 161, 151, right? That's equal to 70. So the answer is 90. Okay, Carol, any questions?
None. None, sir.
Okay. Question 5, Carol, can you read the question?
D is a positive integer. If the remainder of dividing 2009 by D is 7, find the number of positive values of D.
Okay. Here, D is a positive integer. Okay. So the remainder, right? The remainder of dividing 2009 by D is 7. Find the number of possible values of D. What do you understand from here? The remainder of dividing 2009 by D is 7. So that means that if I divide this 2009 by D, okay, D, let's say here we have the quotient, right? And the remainder is 7, right? So now from here, if I just take D, 7 to the left-hand side, then D times Q is equal to 2009 minus 7, which is equal to 2002. And 2002 is equal to 2 times 1001. And what is 1001? As you see, actually, if in the middle of two ones, we have even number of zeros, they're always divisible by 11. So I can just write it as even is divisible by 7. So that is 7 times 11 times 13. Okay. If you divide by 11, that's equal to 91. 91 is 7 times this. Okay. Now, if you look at the left-hand side, right, what's going on here, Carol? Here we have 2009, right? And we are dividing this by D, right? And our quotient is Q. And here our remainder is 7, right? And we know that here, this remainder, right, 7, this remainder must be less than D. That means that D must be greater than 7. Otherwise, the 7 cannot be the remainder. So still I can divide this. But here, actually, what actually D can be here? Can D be 2? No. Can it be 7? No, it is not greater than 7. So it can be only either 11 or 13, right? Or what is it? It can be 11 or 13. All right, let me just write the possible values of D. Since D is greater than 7, right? So it cannot be 2, it cannot be 7, but it can be 11. It can be, the next factor is, it is 13. Or here we have also the product, because on the left hand side, just the product of two numbers. Also, it can be 2 times 7, it can be 14. And 2 times 11, it can be 22. And 2 times 13, it can be 26. Okay, with 3, we are done. 7 times 11, 77. 7 times 13, it can be, what is it? 7 times 30 is 91. Also done. And here 11 times 13, it can be 143. Okay. And all of these numbers, also it can be 2002, right? Also it can be 2002. Okay. Because if you divide 2009 by 2002, remainder is 7. Okay, if you divide by 11, 13, 14, 22, 26, 77, 91, 143, 2002, actually all of these numbers, when you divide 2009 by these numbers, remainder will be 2. So what is the answer? How many possible values? 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have 9 possible values. Carol, do you get it?
Yes.
Okay, if you get it, it's really good. Are you tired?
Mm, not, I mean, quite.
Okay. So what shall we do then? Let me just solve 2 questions, Carol, and I will finish the class. Is it okay? Or you are
Yes.
tired?
Mm, I feel tired for now.
Say again?
Mm, I feel, I think I feel a little tired.
Okay. So do you want to finish the class now?
Mm, yes, since it's almost the end. I think it's the end now.
Okay. Okay, Carol. Okay, Carol, then maybe if I meet again, we will talk about the previous question, or I will just send you the answer. I don't know how. Okay, Carol. Thank you very much. Have a good day. I will meet you next time. Okay. Okay. Bye-bye.